Okay, so on this, Devon is 5 years younger than Sydney. The sum of their age is 95. What's Sydney's age? Okay, first of all, let's say you don't remember how to do it the algebra way in the middle of a test. You say, okay, one guy is 5 years younger than the other, and they add up to 95. Let's see. So, I mean, you could just say, all right, so if one of them's 40 years old, then that means the other one is 35. Whoops, hang on. It didn't quite register. So 40 and 35. Nope, that doesn't add to 95. It's not enough. All right, let's beef them both up. Maybe, I don't know, 45 and 40. Hey, that's getting closer. How about 50 and 45? Hey, that's it. 50 and 45. That's it. I mean, you could just guess and check your way to the answer on some of these. So, so the point is, if you don't remember how to do the algebra, don't give up. Okay. Now, on this one, we have, okay, so Devon's age is being compared to Sydney. Or in other words, Sydney's age is kind of like our baseline. That's what we're comparing things to. Therefore, one way, there's two main ways to do this, and the easiest way is to say, let's call Sydney's age X. Okay. Now, if Sydney's age is X, then what would Devon's age be? Well, it says Devon's 5 years younger. So Devon would be Sydney's age reduced by 5 years. Okay. And we get that. So we are told in the second sentence that if we add their ages together, that'll be 95 years old. So we get 2x minus 5 is 95. And then if we add 5 to both sides, we get 100. Divide both sides by 2, and x is 50. So what does x stand for? Well, x by itself stands for Sydney's age. Okay, so we've got Sydney's age. What about Devon's age? Well, x still stands for 50. Okay, wherever in this problem, x always is 50. So Devon would be 50 minus 5, or 45. So again, we see 50 and 45 years old. And that would be a good way to do it. Again, what I did was I said, hey, Devon is being compared to Sydney. So whoever, we're comparing people to, that's our baseline. That's going to be x. And then the other person or other item or object is going to be something related to x in some way. And that works pretty good. All right, n is the middle number of 3 consecutive integers. Write an expression for the sum. So we're not going to figure out what the integers are because, well, we don't have enough information. And secondly, it doesn't ask us to. It just says write an expression that shows the sum, but doesn't tell us what the numbers are. Okay, so consecutive integers, that's like 29, 30, 31, or 18, 19, 20, just consecutive in order, just without skipping any integers. What are we going to do with that? So n is supposed to be the middle number. Okay, so if n is the middle number, well, this last number is always what? Well, it's always 1 bigger than n. That says n plus 1. I know it's hard to read my writing. Sorry about that. I'm trying to fix it, and I think I'm making it worse. And so these guys here are always what compared to the middle number? Well, they're always smaller by 1. So the middle number reduced by 1. Bam. That's it. Now, what if we threw an extra word in? And we said, let n be the number of 3 consecutive, oh, I don't know, even integers. Well, what do consecutive even integers look like? Well, they look like 2, 4, 6, or 104, 106, 108, etc. Okay. So if we were going to do the same thing, we would say, all right, well, n is still the middle number. And the one that comes before it is always smaller than that by 2. And the one that comes after is bigger than the middle number by 2. So if you do consecutive even or consecutive odd numbers, this is what you get. Okay, so now we do a value mixture problem. So we got a couple of items that we're going to mix, in this case, coffee, but it might be money at different interest rates or whatever. So Omar, his coffee shop makes a blend that is a mixture of 2 types. Type A is $5.95 a pound, and type B is $4.90 a pound. Now he's gonna mix them so that he's got 3 times as much of B as he does of A. So we've got a whole bunch more of B than A, 3 times as much, and so much so that the total cost for him is $5.78.20. So he's buying a lot of coffee, but then again, he's selling it, not just drinking it. So that's what we've got, and I thought, let's just use what the author has. Okay. So we're going to just say, let X represent the number of pounds of coffee A that is used. Why A? Why not B? Well, you could do B, but when the problem starts relating the 2 of them together, okay, right there, when they start relating them together, it says this month's blend used 3 times as much of coffee B as of type B as type A. Now, this is similar to that last word problem we did with the consecutive numbers. The amount of B is being compared to A, and A is our baseline. So we're going to set X equal to A. Again, you don't have to do that, but this tends to be the easiest way to do it. So that's why they're saying X is going to represent the number of pounds of coffee A. All right, so because you got 3 times as much of B, then coffee B is going to be 3X. All right, so notice we've still only introduced one variable, X. The fewer variables you introduce, the easier the problem is to work with, and the fewer equations you have to come up with. So this is kind of nice. All right, now before we move on, think about this. Let's say you want to buy a soft drink at the store and it's $2, and you say, hey, I want to buy 3 of those. How much would that cost? You'd say $6, and I'd say, you're right. How do you get it? Well, you took the cost multiplied by the number of items. Well, that's all we're going to do right here to figure out the total cost, kind of like the $6, to figure out the total cost for coffee A. So we'll take the cost for each pound multiplied by the number of pounds, kind of like the cost for 1 drink multiplied by the number of drinks. And then we do the same thing for coffee B. The price for 1 pound of coffee B multiplied by the number of pounds. Okay. So, yeah, I guess we don't need that anymore. So then we say, all right, well then, since that's going to be the total amount that we spend on coffee A, and that's the amount we spend on coffee B, then if we add those together, we get the total amount that we spend total on coffee. Okay. And so now I need to do this. Okay, I need to zoom out a little. Sorry about that. So then, we just simplify, divide, blah, 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 and we get X is 28. Okay. So if X is 28, X stood for the number of pounds of coffee A. Then to get the number of pounds of coffee B, we just triple that number. okay, which would be 78 pounds. Okay, and that's how these are done. Okay, you just kind of base it off of, whoops, just kind of base it off of that idea I gave you of, well, I know how it works. If it's $2 for a soft drink and I'm buying 3 of them, I know that gives me $6 total that I'm going to spend by doing price per one item multiplied by number of items. Okay, on this one, Chris drove to the mountains last weekend. There was heavy traffic on the way there. It took 10 hours. Wow, that's a long trip. When he came home, there was no traffic, so it was only 7 hours. If his average rate or speed was 18 miles per hour faster on the way home, how far does Chris live from the mountains? Okay, so on this one, there's an easier way and a harder way to do it. And I'm going to give you the way that I think, pretty sure, is the easier way. First of all, we're seeing a lot of distance and speed and time, and hey, that's why they've got that in the title. Okay, so the equation that represents that is dirt. Your distance is equal to your speed times your time, or your rate multiplied by your time. Okay, so we're going to use that to help us figure out this distance. Okay, and so I'm going to get a little bit of the Hobbit on you. So we're gonna, the first trip is there, T for there, and the second one is BA for back again, there and back again, A Hobbit's Tale. Okay, see, I'm well versed in the classics. And now we'll say, all right, well, what do we know? Well, we know that to get there, it was 10 hours, and to get back was 7. All right, that's easy. And we know that whatever his speed was getting there, getting back, it was the same thing increased by 18 miles per hour. All right. Now, they don't say anything about the distance except find it. But we do know that, okay, this is key. We do know that if you multiply a speed by a time, that gives you distance. So if I multiply those two together, I get the distance. And if I multiply those two together, I get the distance. Okay, so I've got 10x, and this is going to be hard. Okay, 7 times x plus 18. Sorry, it's crowded. Okay, and okay, so we know that, but also we also know that the distance on the way there and the distance on the way back is the same because, well, he drove from his home to a destination and then he drove back to his home. So those distances are the same. So we can create an equation that equates the two of them. And then we're home free because we know the distance there and the distance back again are the same thing. So get rid of the parentheses. Subtract 7x, divide by 3, and we've got it. 42 miles. Except, wait a minute, what does x stand for? X all by itself is the speed or rate going there. Oh, and we're supposed to find how far away he lives, the distance. So this 42 is not 42 miles. It's 42 miles per hour. That's how fast he was traveling on the way there. Okay, well, then what's his distance? Well, you can plug it in there or you can plug it in there. Plug it in for x. Either way, I'll do the first one. Okay, 10 times x, which happens to be 42, is 420 miles. Now that makes more sense because remember, it took him 10 hours to get there and 7 to get back. 42 miles, that's if we said 42 miles was the answer, that really wouldn't make sense, because even on a bicycle, you can get there way faster than 10 hours, even if there is traffic. Okay, so 420 miles, that'll be our answer. These are good ones for practice. Okay, this one is actually just like the coffee problem. Okay, it's just like it, except the numbers are different, and instead of coffee beans, it's money. Now, I'm going to handle this one just a little differently than I did the other one. I mean, it's going to look a little different because I'm going to set up a table. And I could have set up this exact same table for the coffee one. I just chose not to. All right, so I'm going to do Q for quantity, R for rate, and then Q times R. Okay. Okay, so we have investment. You know what, I'll just, okay, investment A. So all of this is investment A. Investment B is all that. And then the totals. Okay, and then the Q stands for quantity. So these are going to be quantities of things, and these are going to be rates. Now, I'll tell you right now, rate, anytime you hear the word per, okay, like miles per hour, you're dealing with a rate. You're comparing two things. And then the third and final column is just those quantities multiplied by those rates. Okay, so let's get to it. Let's see. So she's investing in both of them. So she invests a total of $8,000. Or wait a minute. No, she invests $8,000 in fund A. So the quantity for A is 8 grand. Okay. Now they don't tell us how much she's investing in B, so I'll just call that X, just to be super original. Plus, that's what they asked me to find. So not a good reason to do that. Now the rate, I guess we should stick with quantity, I suppose. So what would be the total quantity? Well, they don't tell us, so we're going to say 8,000 plus X. Yeah, just add these together, and that'll be your total amount invested. Now, the rate for investment A, for fund A, is going to be 6%. So notice 6% involves the word per, 6%. So I know, okay, that's a rate. By the same token, 2% for B. Now, for the two columns that involve the Q, involve quantity, yeah, you add these two together to get the last two. But that's not the case with the rate column. Okay. This total rate is actually the average rate. In this case, the average rate is 3%. Notice the 3%, that's closer to 2% than 6%, which means there's more money being invested at 2% than at 6%. So that right there tells us, X is going to be bigger than 8,000. How much bigger? I don't know. We got to do the math. Okay, now this final column is labeled Q times R. So we'll take each Q value and multiply it by its corresponding R value. And I know I'm apparently getting very good at making boxes that are too small. Okay. So now remember, again, I said in the columns that involve Q, you can, when you add the first two together, you get the total. You add the first two together, you get the total. So we're going to use that from the QR column. Okay. We're going to say, well, 8,000. You know what? Maybe I'll just type this out. That'll be easier for you to read it. Okay, so 8,000 times 0.06 plus 0.02x equals 0.03 times 8,000 plus X. Okay. And we get that. Okay, so 8,000 times 0.06 is going to be 480. And 3% of 8,000, 0.03 times 8,000 is 240. Okay, and we've got that. So if we, let's see, subtract 0.02x from both sides, then we get 480 is 240 plus 0.01x. Then subtract 240 from both sides, and we get 240 is 0.01x. Well, I'm glad I did some of this typing because it doesn't take up as much space. Okay. And when we divide both sides by 0.01, we get 24,000. As in $24,000. I know that's a dollar amount because X is by itself right here for the quantity of money invested in Fund B. And just as we expected, the amount going into Fund B is considerably more than the amount going into Fund A. So that is how these are done. Practice, practice.